right, go.
All right, so today we're going to be talking about a volume of a three-dimensional shape. It's not a shape that just has one face to it. I'll try and pick something up that isn't got a mark on. Not something that's just a flat shape. We call that two-dimensional because we have two things I can use to measure to tell you how much space that takes up. A volume is now for three-dimensional shapes. So we would be talking about volume when we're talking about things like a cube, shapes like a rectangular prism, things like triangular prisms, pyramids, cylinders. Those would be all something that we call a three-dimensional shape, and it has a volume. The reason we call it three-dimensional is there are three dimensions to that. I'm looking for a box. I collapsed my box from last week. I'll take a look at it. People say 3D. You just want to make sure that you know that D stands for dimensions. When I'm looking at I'm not just looking at a rectangle. I'm looking for something that also has some height or some depth to it as well. When we are calculating the volume, we want to find out volume. Another meaning for volume is how much space something takes up. So it's related to area. How much space a three-dimensional shape takes up.
Or how much you would need to fill it with something, right?
Or to be filled.
Yeah, so the space within it.
Definitely. That's how it comes up mostly in my life now. Mr. Brown will ask me how much concrete is going to go into this plot of land that he's got calculated out some volume. He'll be asking that question. We'll be talking each other through how to figure it out so he orders the right amount. So volume has three-dimensional shapes. There are shapes like cubes and rectangular prisms. Remember we talked about last week how to draw a cube. So a cube would be a square that has three dimensions. So I'll draw two overlapping squares. A rectangular prism would be having a rectangular face that would overlap.
Is a cube a rectangular prism?
Is a cube a rectangular prism?
Interesting question.
Something to think about. A cube is related to a square. Squares is a square and a rectangle. Is a cube is a square a rectangle? So it would be the similar question to is a cube a rectangular prism? Okay, so when we're going to be thinking about rectangular prisms, I want you to be thinking about things like rectangles. And what makes a prism is it's a stack. If it's a rectangular prism, it's just a stack of rectangles, like these sheets of paper. Once I've stacked all of these rectangles on top of each other, I have a rectangular prism shape. Same thing for a triangular prism. It would be just as though I took a whole bunch of triangles and stacked them on top of each other to add another dimension, a height dimension. I still have the shape, and now I'm adding some height to it. So when we do volume, one way to calculate volume is to do the length times the width. Or actually, one way we do volume is to do the area of whatever shape that is my base times the height. So if I were doing a triangular prism, I would want to know the area of that triangle. And then how many do I have stacked on top of each other? That's where the height comes in. Same thing.
Would A be an A, or would it be a big B?
Now this is the way that I'm thinking about the area, but your book changes that word to A as in big B, where big B stands for the base, the area of the base. So it's an area, but your book is using it as a big B because they want you to think not just an area, not just any area, not any area of any of the faces, but of the base. Remember, base, bottom. What am I using? Using triangles. I'm stacking triangles. Want to know the area of the base? I want to see how tall is it? How high does it go up? If I'm using
Prisms are named by the name of their bases.
I'm using a rectangular prism. This is my base. I want to know the area of this base and then how high. It would change. I'd get the same volume, but if this base, I would want to know this and the height changes. So depending on how I turn this, my area might change and my height will change, but the volume should still stay the same. It should be any of the faces as your area. So base times the height for the different shapes. So if I were looking for a triangular prism, I'm sorry, rectangular prism, if I was going to look for a volume of a rectangular prism, your book has volume written two ways. It has length times width times height, and it has big B times H. So if it was, and so we look at what's different between those two. Big B is really length times width, and we know that that is the area of the base. Length times width or base times height is there. They just go back to length times width here because then it's like which height, the height of width. So finding the area of the shape and then how high up does it go. We'll try an example here with the cards. So this deck of cards looks like a rectangular prism. So we're going to try that. I'm going to go with purple here. I'll hold that up. So if I had the deck of cards, and if I draw it out here, I'm going to draw a little picture because whenever I do any kind of math problem, if I can at all draw a picture that goes with it, I want to do it. Show two rectangles overlapping.
Be sure to practice that. Good note taking.
That's drawing that too. And if you have a deck of cards and if you measured it, and it's a full deck of cards and you haven't lost some, this bottom one down here, no matter what, is 2 inches. It's a standard size, 2 inches. And this top edge here, I probably should be labeling it something different than the same color I drew it in. So let me do better with that. Then this side here would be 3.5 inches. And what I meant was if you haven't lost any of the cards, it should be a 1/2 inch thick if you haven't lost any. So it should be a 1/2 inch here. That's that thickness from here to here. I'm gonna make sure that's on there. So if I've lost a bunch of cards, it's not gonna be a 1/2 inch, but if I have the full deck, I've got that 1/2 inch. So 3.5 inches here, 2 inches on the bottom or on the top, and it's a 1/2 inch thick. And if I stack it all together, it does look like a rectangular prism. So one way to do this problem, I'm going to write the formula down. One way to write the formula down is base. And so I'm thinking about the base. I'm thinking about the base being 1 card. What would this big B be for 1 card? So this big B, remember, is the area of 1 card. So 1 card would be right here. So I'm going to change it, substitute what I know. The base, it's a rectangle. So this is, I'm going to put big B over here. Big B is a rectangle. And it's the area of a rectangle. And it's the area, I'm going to draw a picture over here. I love pictures because it helps me keep things straight. We talked last week when I'm thinking about rectangular prisms, there are 3 different rectangles I could be talking about, but I'm talking about this specific rectangle, the face of a card. Okay. So the area for a rectangle is base times height, or length times width, or length times width. Remember, I always put that L as cursive. So base would be 2 inches. The height would be 3.5 inches. And I do say and here because it is 3.5 inches. So I can figure this out, or for right now, I can just leave it as those two numbers and do it either way. So one thing I could do, okay, 2 inches, 2 over 1, and I need to make that improper. So I have 3 whole sets of 2, which is 6, plus 1 more is 7. Multiply the numerators, multiply the denominators, and I get 14 divided by 2, or I get 7. I could have done it. 2 sets of 3 is 6. 2 sets of a half is 1. So altogether I get 7. I could have thought of it any way. But 7 what? Inches times inches, 7 inches squared. So that's what comes over here in big B. And rather than trying to squeeze all of that over here, I took it over to the side. So now I can do 7.5 inches squared. And if I really wanted to make sure that people would see it, I would just put a little arrow over here saying this is where I did that work. So area is always in inches squared. Volume is area times another dimension. So the units of volume would be cubic units, or to the 3rd power we do it. We call it to the 3rd power, or cubic. A cube has 3 dimensions, so we call it cubic units. All right, now I need to know the height. The height, if this is my deck of cards, this is my base. The height, I love this deck of cards. It's a Coca-Cola deck of cards, and all of the sides have Coca-Cola bottles. The height then is this side is a ½ inch. How many of these have I stacked up? A ½ inch worth. I've stacked up a ½ inch worth of these cards. So this height here is the stack, 1/2 inch. So now volume is 7 inches times 1.5 inch, times 1 inch, ½ inch, 1/2 inch. So I know it's inch squared times inch to the 1st power, which makes me cube. Incidentally, that's another invisible math thing. We've been talking about that. If there's nothing written, it's assumed it's to the 1st power. So we just don't say it. It just is inches. All right. So 7 times half of 7. Half of 7 is 3.5. 3.5 inches cubed. Another popular way, and your book does show it, it would be okay to do it. I could have just said, oh, volume, it's a rectangular prism. I'm going to multiply the 3 dimensions because I know that the area of the base is length times width. I know it's 3.5. I know it's length times width times height. So this would be length, this would be the width, and this would be the height, or any way I want to label it. And I just know I multiply all 3 dimensions. 3.5 inches times 2 inches, and I exactly labeled it different. Doesn't matter. 3.5 inches times 2 inches times 1/2 inch. And I could write it that way. And I know it's going to be inches to the 3rd power, an inch times an inch times an inch, 3 of them, 3rd power. When I think about it this way, well, half of 2 is 1, so just times 3.5. It might be an easier way to look at it sometimes, sometimes it's not. Either way, I've done it 2 different ways now, and I've got the same answer.
Oh, I like that. So you looked at the half. Half of 2 is 1, and 1 times any number is any number, so it's 3.5 without working out the math. I like that. Always looking at the numbers to see what the relationship is a really good idea. Another way we could have done that was we could have checked it with a calculator, and we could have turned, since we can't put fractions into a calculator, what we would do is we would convert 3.5 to 3 5/10, and we would convert 2, we would leave, and we would convert 1/2 to 5/10, and then we could multiply those in a calculator. That green's hard to read, but those could be decimals.
You said the green's hard to read. I can go.
To read. Maybe you could write it. Yeah, that's better. Thank you. And then you could just double check it in the calculator.
Another way to do it, for sure.
All right. So that is how to find the volume of a rectangular prism.